All right, this is going to be 2.1. I think I'm going to try writing with the bigger markers because it's a little bit of a darker piece of paper here. So hopefully that helps some. 2.1 is representing relations and functions. So some definitions really quick. I'm going to try to go down to the smaller ones really. If y'all have trouble seeing these markers in the video or anything, just let me know in class, and I'll try to go to the bigger ones since this is a darker piece of paper. A relation is mapping or pairing values, or pairing of input values with output values. Okay, I don't always define the terms, but I'm going to define a couple of these just because they should be relatively new. Domain are the input values. Okay, and these are always going to be our x, whoa, wrong marker, sorry. These are always going to be our x values. And then range is the output values. Okay, and these are going to be our y values. All right, so then we have 4 different ways to represent relations. Okay, so different ways to map it or to show it. So we can do that with, let's see, 4 ways to represent relations. Just drew a line right through that. All right, so the first one we have is by ordered pairs. Okay, so we have -2, 2, -2, -2, 0, 1, and 3, 1. We can do it with a table, so like an XY table. So you still set it up the same way. You can graph the points. Okay, so I'm just going to ballpark, get these points in the right spot. Okay, so I just ballpark got those in the right spot. And then lastly, we have a mapping diagram. Here we use mapping, so we have the input values, we have output. Okay, so we have -2, 0, and 3. Okay, these do not repeat. I had 2 -2s for the input, so I don't write it twice, I only write it once. For the output, I have -2. Oh, I also had a +2. And 1 is used twice as well. Okay, and then what happens is, I'm going to do this in another color just so you can see it. Okay, they're always going to be in circles. Okay, and then when you are connecting them to what they go with, okay, -2 goes with -2. It also went with +2. 0 went with 1, and 3 went with 1. Okay, so it goes like that. And we'll do examples of actually setting them up and stuff like that in class. But I wanted you guys to go ahead and get a feel for it now to see them. So we have another definition here that we need to talk about. It's a function. which is a relation for which each input has exactly one output if an input has more than one output, it is not a function. Okay, so in this case, an input had more than one output up here. Okay, this one input had two outputs. This would not have been a function. Okay. And like I said, we'll look at examples of that and how to tell if they are or are not in class. We have what we call a vertical line test. So when we graph, we can see if it's a function or not. And so for this, a relation is a function. Okay, FNCT is how I write function, so you'll see that a lot. If and only if, okay, you should remember if and only if statements from geometry, but if and only if is what IFF means. I didn't just spell if wrong. So if and only if no vertical line intersects the graph of the relation at more than one point. Okay, so quick example of that. If I have two graphs drawn here, I have one that's a right side up parabola and then one that's opening to the right. Okay, my vertical line test would be a line straight down through it. Okay, the best way to do it is with your pencil, is to just slide it over and make sure there's no point that hits more than once. Okay, so since this one does not, it only hits in one spot, it's a function. Okay, but this one, if I were to draw a line down through my function, or if I were to follow it over, for every x value, there are two y values here. Okay, so this is not a function. Let's see. I'm trying to decide. All right, really quickly. Let's see. We have graphing equations in two variables. You should be familiar with that. It's like graphing a line or something, plugging in points and getting it. Equations in two variables, though. The independent variable are the input values sorry, not the input values, the input variables, okay, which is going to typically be your x, okay, your dependent variables, be your output variables, Okay, and then an ordered pair, which you probably already know this, but an ordered pair is a solution, okay, SOLN is solution, I don't know if I've said that one before, of an equation in two variables. Okay, if we had an equation with three variables, it'd be an ordered triple, things like that. Also, I know this is a little over 10 minutes now. I promise I'm almost done. So if we were to be graphing, we would make a table, plot the points, blah, 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 so on and so forth. I have two more definitions really, really quick, and then I promise it is going to be done. A linear function can be written... Oh, this marker's dying on me. I know y'all can't read that. A linear function can be written in the form y is equal to mx plus b, where m and b are constants. Okay, so that's slope-intercept form. Function notation is the last definition here. Renaming y as f of x. Okay, so y and f of x are the same thing. Okay, so in xy notation, we have y is equal to mx plus b. In function notation, we have f of x is equal to mx plus b. Okay, and f parentheses x is red, f of x, just in case you are curious. I know I kind of ran through those last definitions kind of fast. Also, sorry, that's like really light. I don't know what is going on. I think it's like blurry, so. Anyways, not sure that that really just helped anything. But that is all. We'll do a lot of examples of stuff with this. It sounds kind of scary initially, but I promise the actual problems are really easy. So yeah, again, sorry this is really long, but it's a lot of definitions and stuff that we needed to get out of the way before class.